Well, taking that photo was fun. I'm sure some of you actually feel like that right now in this class, in this first week. And after my email, a lot of you have responded to me saying, hey, I'm feeling a little overwhelmed in this class. There's a lot to know. I just made a video on how to use Learn, and I'm going to actually email that directly to you, because why would I post a video on how to use Learn when you don't know how to use it? So I'll have them in both places. I'll email it to you here soon, and then I will also post it in Learn for you as well. And like I said, it's a quick little 11-minute video of how to use it. And then I'm also working right now on how to do some how to learn, like not how to use the program Learn, but how you can learn how to study and study tips for this class, and a little bit of my teaching philosophy as well. That way you know where I'm coming from. Okay, so this is our first week. And as you've noticed, there's a lot to know about this class. So if any of you have any questions, go for it. You can shoot me in the live chat over here, and I can answer your questions as they come up. So the questions that I've been getting from emails have mostly been, where's the syllabus quiz? Where's the quiz? Where's the reading material? And all of that stuff is, if you look at the course home tab, which I explained in my video, you click on that course home. Excuse me, I'm drinking Diet Pepsi here. Go to course home, go to week 1, go under graded stuff, and everything that's supposed to be turned in this week is under that graded stuff. And then under instructional material, that's where you'll find all the required reading. You'll find a podcast, you'll find PowerPoints, and you will find also all the YouTube videos, along with some practice problems. And as I've said earlier, the practice problems, they are not required. They are there to help you learn the material. That is it. Okay. What's the difference between this biology and biology lab? I have 2 different professors. Okay, so traditionally you would come to a lecture class. I do the lecture part of it. And then you have a lab that you would go to once a week, and you would have a TA that was in charge of that lab. And that TA is coordinated by Dr. Satya Witt. So in the lab, you're going to be doing different types of experiments. Now that it's online, if you're taking the lab, you'll be doing online experiments. But this is basically, this class is the lecture. Okay, next thing I've got is any tips for the science and digital literacy assignment. Yes, I do have tips for how to do the science and digital literacy. Now, first of all, if you go and you look under course information, I put a 1-page write-up of how to do the science and digital literacy. But here's my tips. First of all, the word minimum is 200 words. Now, that's just the body of the paragraph. That's not your name, date, title. That's also not any citations you have or anything that you've quoted in there. And that just guarantees that you won't get a 0, right? So my tip is, you need to look at the 2 websites, review them, and then you might have to do some additional research. Look up who wrote the website, who's doing them. Does a website use emotional language or not? And spend some time explaining how you came to your conclusion that you chose the right website. And like I said, that additional research is very important. So if there's a website on homeopathy, well, what is the scientific consensus on homeopathy? Is there a scientific consensus for or against it? So if you find a web page and the science is against that, I'm not talking about pop culture, because when you do GMOs versus GMOs versus organic farming, you're going to find a lot of propaganda against GMOs and for organic farming. So you need to go into the science of that and really explain well. So the students that do very well on those typically are around 400 to 500 words. Now, some that write about 300 also get perfect scores. But like I said, that additional research is important. And part of my goal here is to get you guys to go out and look stuff up and not rely solely on what I'm saying or just the book, to actually learn how to use resources and look that stuff up. So that's my biggest tips here. Also, about 30% of your grade is grammar and spelling. Now, I'm not a grammar. I'm not like hardcore on grammar. I don't care if you split your infinitives. I don't care if you have dangling participles. Those aren't that important to me, but make sure it's very readable. That's important. Also, don't write it like a text message. I'm not your texting buddy. I'm your professor and I will grade you. Now, you don't have to write super formally. Writing with a voice is also very important, but just make sure you get the grammar down. Put those commas in the right places. Capitalize your I's. Those things are important. So those are my tips for the science and digital literacy assignment. Okay. If anybody else have any other questions, like I said, I'm looking over to my screen on the right. You can send those questions to me right now. But before I move on, I want to talk about chapter 1 a little bit. Now, chapter 1, a lot of you are going, wow, that's a lot of information for a first chapter. And you're right. Welcome to science in college, right? Even our non-majors courses is probably a bit more rigorous than what you've had in high school. Well, this is college. This is not high school. Now, that being said, it's not that difficult. You just need to sit down with it and study it several times throughout the week. And if you try to cram everything all in at once, if you try to answer all your quiz questions by opening up the PowerPoint or the reading and trying to do your quiz in 15 minutes, you won't do well. But let me talk about this chapter a little bit. It's one of my favorites because it really talks about the nature and limitations of science. And I started off with a quote from Carl Sagan, the late Carl Sagan. He was an astronomer. And he said, "Science is much more than a body of knowledge. It is a way of thinking. And this is central to its success. Science invites us to let the facts in, even when they don't conform to our preconceptions." That is important. Science, in this science class, yes, we have memorization, but science is not about memorization. Science is really a way of understanding the world around us. And science right now matters so much in our world. And unfortunately, when we don't have science, bad things happen. So in this chapter, the introduction, I talk about like how I got my start in science really in the 6th grade, even earlier than that, but I read a book called Cosmos that just basically changed my life because I understood what science was for the first time. And so Carl Sagan is a little bit of one of my heroes in life that I always read about. Okay, so this introduction to science, I talk about things like, I quote him again, I said, "We live in a society dependent on science and technology, and hardly anybody knows anything about science and technology. And we've suffered the death of experts, and people think scientists were wrong before, so why do we listen to them now?" Well, I put up an extra reading about that, and I discussed this big time in this chapter. And I talk about there are no such thing as alternative facts or alternative medicine. There are facts and there are things that medicine that works. And there are also limitations to science, and that is important. You know, science is limited to the natural world. Yeah, the natural world, that's important. And that's anything that is at least potentially observable and measurable. If there's no way to at least potentially do something, observe it or measure it, then it's probably outside of the realm of science. And I talk a lot about that. So I talk a lot about the origins of science, and the findings of science is repeatable. If I go out and find that the climate is warming, for instance, through global climate change, then other scientists should be able to replicate those results. And well, that's what we have. Thousands of scientists have replicated the results of global climate change, right? And science is also a process. It's a process of understanding the natural world. So we change and we grow. And sometimes we're thinking one thing in science, and then later on we realize, oh yeah, we were wrong there. So we get it right. So for example, like with this COVID virus, when it first came out, they were saying, don't wear a mask. So now they're saying wear a mask. And a lot of people take that to mean, well, they told us this and they told us that. How can we trust them? Science is a process, and it keeps accumulating knowledge. And as we accumulate more and more knowledge, we home in on the right answer. So initially with that mask, they're like, well, you know, it doesn't really protect you so much, and we need the health of people to have it. And then I realized that a mask doesn't necessarily protect you as much as you breathe into your mask and you help protect everybody around you. So wearing a mask is incredibly important for helping to stop the spread of COVID. Mainly by, if you're infected and you don't know it, it will really help stop that by you, when you go, I just blew out millions of bacteria. No, nobody's around me. I'm in my room by myself here, but I just blew out millions of potential viral particles. And if I have a mask, it catches them all right there. That's why wearing a mask is essential. So science, we figure this out through science, right? Science matters a lot. Okay, so in this chapters, I talk about how science begins with making observations, just observing the world around us and then asking questions. And a big step in science is, you got to have this curious mind, right? You gotta be making observations and asking questions. But science then takes our questions and we formalize them into testable hypotheses. Now, I know most of you have learned in past that a hypothesis is an educated guess. No, it is not an educated guess. I'm not guessing, and I have no idea what an educated guess means. What a hypothesis is doing is I'm making a prediction of an outcome, or I am making an observation, or I'm making a prediction of an outcome that might happen. And we can test our hypotheses and potentially falsify them. And that's important. Okay. And the reason why we actually, in science, when we are testing our hypothesis, we're not really trying to disprove our hypothesis. We're not trying to prove our hypothesis. We're trying to disprove our hypothesis. And the reason why we're trying to disprove our hypothesis is to prevent something called confirmation bias and anecdotal data. So for example, Diet Pepsi. I have a horrible soda problem. I'm sorry. I love my Diet Pepsi. Every day I drink a Diet Pepsi, I don't get sick. Does that mean that Diet Pepsi is keeping me healthy? Well, that would be anecdotal data, right? My wife drinks Diet Pepsi. She doesn't get sick. Oh, that data point confirms my bias. Of course, that's basically ridiculous. This is no way medicinal Diet Pepsi. Sorry, Pepsi. It tastes really good, makes me happy, but it doesn't prevent diseases, right? So that would be anecdotal information. That would be cherry picking the data. And the reason why we try to disprove our hypotheses is to show that, like, my anecdotal Diet Pepsi doesn't work for keeping me healthy. Okay. And then in this chapter, after we talk about hypotheses, we talk about how we test our experiment or test our hypotheses. One way is through observational studies. I would take everybody, a random sampling of 10,000 people. How many of them drink a Diet Pepsi every day? How many of them don't? And we would look to see who got sick, who doesn't on any given day. And of course, we would probably find out that this is not medicinal, that you have that everybody has an equal chance of getting sick based on whether or not they're drinking this. And then we can do experiments where we could actually randomly assign 1,000 people to drink Diet Pepsi every day and 1,000 people to not drink it. And then we can actually get at that question. And as we go on to talk about observational studies, I talk about the limitations of observational studies. Correlation does not always equal causation, but I also talk about the benefits of observational studies. A great benefit of an observational study is, if you want to know the effects of smoking, drinking, a bad diet on people's health outcomes, well, it's unethical to do a manipulated experiment. I can't take, say I got two sections here, you're both about 100 students each. And if I said, okay, section 1, you're going to drink, smoke, and eat pizza every day. Section 2, you're going to go on a high vegetable diet. Well, that would be unethical. So we do observational data experiments where we collect information on people and then we look at the outcomes. So that's a real benefit of an observational experiment. I also talk about manipulating experiments. That is where we actually manipulate a dependent variable. So for example, if you were curious about weightlifting, does weightlifting actually increase bench press? You would take one group, they would not bench press. You would take another group, you would have them work out for 6 months, and you'd measure their bench press later. And that would be your experimental group, and the group that didn't work out, that would be your independent group. And then you could see like the difference in the bench press of those people. And you can also do that for exercise, like how much cardio do you need to do diets. Okay, there's also a limitation to experiments. Like I said, one of the limitations of experiments is that if it's unethical, you can't do it. It might be too expensive to do it. So we go back to our observational experiments. Okay, so the scientific method, science starts with making observations and asking questions. We formalize that into hypotheses that we can go out and test. And we can test our hypotheses by doing either observational experiments or manipulated experiments. Then when we get all that data back, we analyze it. And we can analyze it using descriptive statistics where we get the average, the median, the mean. So whenever you guys give a test, I'll describe how well the class did by looking at the average or by looking at the median of that. And then the other thing that we do are statistical tests. Let's say you've got two groups and you want to figure out, does an hour of cardio a day cause weight loss? And not everybody is going to lose the same amount of weight. Some people might gain weight, some people might not change, some people might lose weight. So you can either gain weight, stay the same, or lose weight. So we would take a statistical test like an ANOVA or a t-test, and we would ask the question, are the differences between the two groups random or not random? And we're not going to do too much of that in this class. Okay, so that is the scientific method. And the other thing in this chapter that's very important, science is a way of thinking, okay? It's a process. We make observations, we ask questions, we go out and test our hypothesis, we analyze our data, and we accept or reject our hypothesis based on our data. And like I said, we try to disprove hypotheses to prevent confirmation bias. Diet Pepsi keeping me healthy here. That would be confirmation bias. If I tested it, I'm sure I'd reject the hypothesis. But science is this way of understanding the world, and it does change over time. And science is not limited to just understanding the natural world. We can apply the methodology of science to almost every aspect of our life. So the scientific method can be widely used. We can use it in economics. Back in the 1980s, they came up with this idea of trickle-down economics. Cut taxes on the rich. They'll save money, and that will trickle down to the middle class. Well, 40 years later, it doesn't work. There's still people that think that trickle-down economics works. It does not. And every economist that studies this goes, there's no evidence for that. And the way we know that it doesn't work is because we have evidence. We have data that show that when you cut taxes for high income tax bracket, the savings does not trickle down to the middle class. And as a result, we've seen a spread, a separation of the very wealthy from the rest of the world. The rest of our country. We can use it for gun control. Boy, talking about a hot button issue is gun control. Wow. We can actually use a scientific method to collect that data. And in this, I actually talk about how the government, how Congress in the 90s actually passed a Dickey Amendment, which prevented the Center for Disease Control, the CDC, from collecting gun violence data. How dumb is that, right? Let's not have data to help solve one of our problems. Anytime you have a problem like economics, gun control, even science and COVID-19, you need data to understand it. And it's data that shows that wearing face masks actually helps slow down the spread of the COVID virus. And we see that. Look at New Mexico. Lujan Grisham has enacted all these things where we're wearing face masks, we're trying to stay at home more. And guess what? We have much lower infection rates than our neighbors, Arizona, Texas, and other areas that are not doing the self-isolating and wearing the face mask as much. Okay, so science matters for all walks of life. Okay. The other thing I talk about in this chapter are things like facts, theories, and laws. And facts, gosh, I never thought I'd live in a world where facts are under attack and people don't agree on facts. But from a scientific point of view, a fact is something that actually exists. A fact is something that happens. The sun rises in the east, it sets in the west. That is a fact. There are no alternative facts. Another one is a scientific theory. Theories, you keep using that word. I do not think it means what you think it means. That's from The Princess Bride, by the way. You keep using that word. I don't think it means what you think it means. And that's the way it is with a theory. A theory in science is a broad, powerful explanation for a set of observations. And scientific theories have yet to be disproven. So good examples of scientific theories are the theory of relativity, both the general theory and the special theory. The special theory of relativity explains gravity. That's important. The theory of evolution by natural selection. Theories explains how the world works. So general relativity explains how gravity works. Evolution by natural selection explains how evolution works, right? So theories are very, very, very important. And they're not just some harebrained idea that's been floated out there. Oh, I have this theory that Diet Pepsi prevents me from getting sick. That's not a theory. That'd be a hypothesis because there's no support for that. Scientific theories have been well supported. Now, a law tells you what's going to happen every single time under the same circumstances. Here's a bottle cap. I'm going to drop it. There it is. Drop. Oh, I almost didn't catch it there. All right, here it is. Drop it. That bottle cap dropped at 9.8 meters per second squared. And I can drop that same bottle cap anywhere on this planet, and it will drop at the same speed. And that is the law of gravity. Thank you, Newton, for that one. And the law of gravity say that every time I drop a bottle cap, it will fall at the same rate. It does not explain gravity. That's Einstein's general theory of relativity. Okay? So make sure you get those differences between facts, laws, and theories because they really matter. Okay, and I also talk about laws of thermodynamics. And then I start talking about the end of it is critical thinking. Critical thinking is the ability to analyze data, to analyze what's out there, evaluate it, make sure it's accurate, and then make informed decisions based on good evidence. So I talk about vaccinations and why they're important. Before COVID, we've been having a problem with lots of people not getting vaccinated, and as a result, some diseases that we've almost eradicated have been coming back, which is pretty sad because, we almost got rid of them. And a lot of the reasons why people weren't getting vaccinated is they cited this link between vaccinations and cognitive impairment, basically thinking it caused autism. That's, I almost said a bad word. That's bull blank. You get the idea. That was based on a fraudulent experiment. It was fake. The guy made up the data in the 90s. Not only did he make up the data, he harmed autistic children. Wow. So even though he got it published, it was retracted as a fraud. He lost his medical license in both the UK and the US for making up data. And the reason why he made up data was so that he could make money off the fallout, right? Off the fallout from linking vaccinations to autism. So, wow, this is all about money. And today, there's groups out there that still bring in Andrew Wakefield to talk about the links between vaccinations and cognitive impairment. So anytime I hear politicians say that, they're lying or they're completely don't know what they're talking about. Because like I said, that fake experiment still haunts us 20 years later. So vaccinations matter. And then the last thing I talk about is alternative medicine and pseudoscience. And pseudo means false, so false science. And so there's a lot of stuff out there about alternative medicines. There is no such thing as alternative medicine. There is medicine that works based on evidence, and there is everything else. Now, that being said, we do study herbs, spices, plants, fungus, bacteria. We scour the earth looking for chemicals that they produce that can help us, right? So we do actually get a lot of our medicine, about 50% or so, from from the natural world, from plants. And so, it's important to study this stuff, to study this turmeric lower cholesterol. It's important to study these things. And then we can get at whether or not it actually works or not. And if it works, hey, it's medicine. If not, it's pseudoscience. So a good one that has been disproven over and over and over again is homeopathy. It's junk science. Okay. Well, that's kind of the introduction to chapter 1 this week. And I've only got the 2 questions. So I'm going to sign off now. And I will be back online again soon next week. And look for the links to how to learn and how to use Learn. All right.